So what we want to do is resolve coplanar forces. Okay. Now, in order to be able to use Lami's theorem, first, the forces that are acting at a point must be coplanar. Okay, and there must be three. That's the only place where Lami's theorem has a limitation. Okay, because remember we've done resolution of this kind of force before, right? We've done this one, right? But when there are three, just three, then this thing I want to teach you applies. Exactly. So now, right, the condition for using Lami's theorem are: one, the forces must be coplanar. Forces are coplanar. Forces are coplanar. Number two is they must act at the same point. So meaning that you're looking at them from the source. It's like they are co-initial also. Co-initial forces. Exactly. They must act at a point, and they must act at the same time. Acting at the same time is called concurrently. They must be concurrent. Okay? Concurrent, that's the word. They must be co-initial, coplanar, and concurrent. Does it make sense? That's they acting at the same time. Alright. So now, right, Lami's theorem. Let's state what it says first. Lami's theorem. Lami's theorem states that if three forces act at a point, if three forces act at a point, the magnitude of each, act at a point, the ratio of the magnitude, the ratio, put ratio there, the ratio of the magnitude of each force, the ratio of the magnitude of each force to the sine, S-I-N-E, to the sine of the angle between the two other forces. To the sine of the angle between the two other forces is constant. Is what? Constant. So this Lami's theorem is born from sine rule. Do you remember sine rule? A over sine A is equal to B over sine B equal to C over sine C, and blah 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 like that. Do you understand? So this is where it is born from. So then let me show you three coplanar forces. The typical one in your exam is this. You have a structure. Say for example, this, I now attach a rope to a load. I attach a rope to this load. This body is going to have a weight that acts downward, right? From its center of gravity, it has a weight that acts downward. Maybe we should even do equilibrium today. This is also equilibrium, exactly. See, another thing is this is in equilibrium. This body is said to be in equilibrium. Then there is a force that is now pulling it in this direction. Then the body now, the question will now ask you, your exam, they will now ask you different things. Exactly. Usually what they will give you is the angle between here. And then you are like, how do I go about it? So here is it, here it is rather. First draw out all the forces that are acting on this body. We call it the free body diagram. Have you? Okay, free body diagram. So in the free body, we should depict the forces acting on that body, on this body. The first force is the one that your hand is pulling it. I hope you understand this system. Do you understand it? For example, this is my bag. I tie it with a rope to this place. You know, normally you should dangle like this, you just stay like this. But now, to tie another rope and I'm now drawing it in this direction. Do you understand now? So that it stays like that. So the body is in equilibrium. All right. So now first we need the free body. The free body will look like this. A force is acting in this direction. A force is acting in this direction. Another force, this one will not be depicted to you. Usually they will not even show you like this. But you are going to know that the weight of an object usually acts where? Straight downward. Is that clear? So this is the weight of the body, which is the mass of the body times what? G, acceleration due to gravity. All right. So let's draw all the forces acting. One is acting there. This one now, there's a force that will be acting on the rope. Well, at least now we know the one acting downward is W. Which one is acting on the rope? Which force acts on strings? Tension. Is what? Tension. So tension in the string is going to act in which direction? Who can tell me? Will it be upward or downward on the string? Upward. Can you prove it? Let me show you something. If I tie a rope, is easily seen in tiny strings. For example, you use cotton wool. I said cotton wool. Wool, normal sewing wool. I tie it like this. Thread. I use it to tie something heavy. Once that thing, if I snap cut it, that thing will fall, right? But where will that rope, where will it go? To go up, right? So it means there was a force that was acting upward when it was holding the thing. Yes, and so that proves it. So that force is called tension. So these are the three forces. So now let's now use Lami's theorem. For Lami's theorem, you need to get this angle out. Let's call this theta. Get this angle out. This one, for example, this will be 90 granite. But it's not always 90. But in your exam, they usually give you one that has 90. Do you know why? I've told you you don't need calculator. Okay? So, just remember the hand trick for sine, cos. Just remember the hand rule. Okay, I'll show you again. Look at it. So this guy here, 90 granite, then this another angle, let's call it alpha. So to get any of the forces here that is not given, usually they might not give you the tension, they will ask you to find tension. They might give you the F. Simply take what Lami's theorem says that the ratio of the magnitude of the force, let's start with tension. The ratio, tension over the sine of the angle between the two other forces. Sine 90. Or any angle here, exactly. But here is 90, so there isn't 90. Will be equal to, they said it's constant. Lami's theorem says it's constant. So this ratio, A over sine A, making sense now, will be the same as F over sine what? Sine alpha. This is how to look at it. See, this is the force, this is the line of the force, right? So the line of force is facing this angle, so it will be over this angle. The line of force is facing this angle, so it will be over this angle. Then it will be the same as W over. Do you understand now? So anyone you are given, for example, they might give you mass. If they give you the mass of the body, just times it by G. You have gotten the weight. So weight over sine theta is equal to T over sine 90, and you are good to go. Is it clear? It's very simple. Let's write this, put that down. Then let me give you a question here. Okay? There's a question like this. The angle is given here. Now look at this one. two things are suspending the load. So we'll solve this one together, then I'll give you your own classwork. Is it clear? Now this is not the sort you see in JAM because this one, bless you. Let's do 60-30 so that it will be easily, we can solve it without calculator. Exactly. So in order to solve this question, the first thing we have to draw is the free body. The free body will look like this. Because all these forces will be acting at the center of gravity of this guy, right? So the weight, what is acting outward? Weight, right? What will be the weight of this body? 80 times 10, which is 800 Newton. Now, don't forget that there's an angle 60 here, there's an angle 30 here. Granite. There is tension in this string, tension in this string. Now, what the question will say, this tension 1, tension 2, they are different because they are different strings. The tension in them are different because they are different strings. Now, what this thing will ask you to find is maybe tension 1, for example. How do we find tension 1? First, we need this angle, and this angle. Make sense? How do we find this angle? We use, what is it called? Lines and this in our land. Do you remember? Simply bring this guy. You know, this guy is straight down, right? So these two lines will be parallel. So if this is 30, this is what? Does it make sense? And if this is 60, these two are also parallel. This will be what? 60. So here, what do you have? 90 Ghana. Does it make sense? Now also, if these two places are parallel, angle on the straight line use it to find it. So what would this place be? 150. Make sense? Angle on the straight line also, what would this place be? 120 Ghana. Angle on the straight line here. So this place is 30, we got this to be 30, so the remaining will be 150. Is it correct? Or another way to think of it, since this is Z here, this is Z, this place is 30, this place is 30. Okay, it means this place will be 50, this will be 150, this will be 150. Is it clear? Thinking of it as Z like this. We equal. And this one, you know, this is not maths. It's in maths that we can have weird lines. Here, we know this is straight down. This is also straight down, so they have to be parallel. So to find T1, it will be T1 over what? 120 Ghana sine. Don't forget the sine of that angle between the two other forces will be equal to the one we have. No, let's do W, because W is one we have completely. We have the size and the angle. But we use T2 here. T2, we don't know T2, but we know the angle. So to me, we have two unknowns. Is it making sense? So W over 90. Is it clear? So from here, what's W? 800. So T1 will be equal to sine 120 equal to 800 over sine 90. Now to solve this without a calculator, I'll quickly remind you of what I taught you. Isaac's hand. No, Adam, this is hand. Is this the right hand or left hand?
Right hand. Left hand.
This is right. So what do you do? Now what? If the person is doing like this, I am doing like this. Okay, that's good though. That's correct. So watch. Let's do it this way. For your exam, this way you should do it. So for your exam, you do like this. You now divide each finger into two. Divide each finger into two. Now, here, put S, C, S, C, S, C, S, C, S, C. Then from here to this place, number 0 granite, 30 granite, 45 granite. Those are the angles that you will need for exam, so that you'll be given or you'll be needing. 60 granite, 90 granite. Why are you looking like you don't see it? So what you want to do is keep this somewhere, that any answer we get, it will be root of that answer over 2. Over 2. So for example, if you are looking for sine 0, what will sine 0 be? This is how you find it. How many fingers are on this side after sine? Sine is on this side, right? How many fingers are on this side? 0, right? So it will be square root of 0 over 2. Square root of 0 is 0. 0 over 2 is 0. This is the proof that God knows math. I'll release a video on it. I'll put proof that God knows math. Honestly, I'll do it.
Okay, then I'll.
Yes. Yes. Ah, thank you, Jesus. People want it. Let's go. So, sine 0 degrees here. Then, if it's cos 0, cos is on which side? That side. How many fingers do we have on that side? 4. So, it will be root of that 4 over 2. That will be 1. I mean, sorry, 2 over 2. So, cos 0 is what? 1. Let's do sine 30. Sine 30 will be, sine is on this side. How many fingers do you have here? 1. So square root of 1 over 2. 1 over 2. Don't forget, it is always root of whatever you are saying over 2. If it's cos 45, cos is on that side. How many fingers are on that side? 2. So you have the square root of 2 over 2, root 2 over 2. Exactly. Now for 90, what will sine 90 be?
0.
Sine 90 is...
Okay, fine, that's 4 over 4.
Yes.
That's 1.
It's 1. Exactly. Sine 90 is 1. So we said that that's the trick, okay? Do you still remember now? Alright, so here, sine 120. Watch, let me show you something. The sine of an angle theta is the same as the cosine of 90 minus that angle. Do you remember this? In when we were doing Coplanar forces, that if you do cos of this, it's the same as sine of. Do you remember? So it's the same case. Now here, the sine of an angle also is the same as sine of 180 minus that angle. So here, sine 120 will be the same as sine 60. Is it clear now? Alright. So you see, you don't need calculator. Just remember that sine of an angle is the same as sine of 180 minus that angle. So here, t over sine 60, what will sine 60 give me? Root 3 over 2 is equal to 800 over 1. Cross multiply. You have t times 1 equal to t is equal to root 3 over 2 times 800. Here 1, here 400. The answer is 400 root 3 Newton. That's the answer. This is the answer, the kind of answer you see in your exam. Is it hard or simple? Simple? Should I give you one? Copy it and do this one. That one end of a string is fixed to a point P and the other end is hooked to a block of mass 15 kg. Okay? So there's a block of mass 15 kg. Let's draw that. 15 kg mass. So when a horizontal force Fn is applied to the block, horizontal force. So let's put that force here, for example. Let's put it on positive side. There is no problem. F Newton is applied to the block. The string is inclined at an angle 30 granite to the horizontal. So there's a rigid structure here. The string is now attached at 30 degrees to the horizontal. Where would the horizontal be? Here, right? 30 degrees, because it's horizontal. If it's to the vertical, it will be here. Alright. So the weight, there's a force acting from the center here downwards, and that's what? The weight of the body, which is 150 Newton. Mm. Does it make sense? Mm. Please, once you are done with those videos, let me know and I will know the next one to send. Because we are not doing, we did not do projectile motion, but I have a full course on it, so I'll send it to you immediately. Exactly. So please, let me know immediately and work harder. So now, if this is 30 granite, what will this place be? 30 granite using alternate angles. Okay, let's draw the free body. So the free body will look like this, this, this. Make sense? Now, if this place horizontal is 30 granite, what will this place be? 90. Everywhere will have what? 120 granite. What will this place be? 90. Don't forget, weight is always straight downwards. Then this place is what? Just add this and subtract from 360. 360 minus 210, 150. That's what we did the other time. So what does it say we should find? The tension in the string. So we should find force, tension, force F, and we have weight 150 Newton. So using Lami's theorem, one of my students said the way to remember this thing. Not last year, or was it last year? One of my students somewhere just said that to remember, he says Olamide. Using Olamide's theorem. You know why? She said she had a friend that bears Olamide, so they call her Lami. So using Lami's theorem. So it will be 150 over what? I'm taking the one we have first. Is that clear? 150 over sine 150. It is this over the angle that is facing it. Is that clear? Will be equal to find tension. Tension over sine 90. Good. So from here, cross multiply. T sine 150 is equal to 100 times 1. Divide both sides by sine 150. Thank you. Yes, sine 150. This takes care of this. And T will be equal to 150 over, what is sine 150? Sine 30. What I showed you. 150, 30. So sine 30 is what? 1 over 2. So this guy goes up 300 Newton. Is it out of simple? So just know how to interpret it. Then the Lami's theorem says that the ratio of the magnitude of a side to the angle between the other two forces. This is the angle between the other two forces. And the way to look at it is this force here, the angle in front of it is this. This force here, the angle in front of it is this. So it will be T over sine 90, F over sine 120. Is it clear? Alright. No. So find the horizontal force for me. What will be the value of the horizontal force? So put the answer in the comment section. God bless you.